Let's start with the linear second order differential equation with constant coefficient. What is the general shape? You have two type of this one, homogeneous and non-homogeneous. Okay. What is the difference between this one and this one? This one has a shape y double dash, and you have a constant coefficient here. Let's start y dash and y equal to, if it is homogeneous, you don't have anything to the right hand side, everything in terms of y only, and you have a constant coefficient here. Okay, this constant coefficient will help you to solve this homogeneous differential equation. Okay, and non-homogeneous, it will be the same shape, but you have a function of x in the other side. Okay, and also the coefficient is constant, are constant. Okay, how to solve this one, the homogeneous one? Easy. If you let the solution y equal to e to the mx, of course, when you differentiate, you will have y dash equal to m e to the mx. Differentiate again, y double dash e to the, sorry, y double dash is m squared e to the mx. If you substitute in the differential equation, you have a, yes, and y double dash m squared e to the mx plus b, what's y dash? M e to the mx. What is y? Y is here. E to the mx equal to 0. Now you can divide it by e to the mx because you guarantee e to the mx is always positive, right? So you can divide it. So you end up with this one is becoming algebraic equation. A m squared plus bm plus c equal to 0. Okay. By this substitution, this one is becoming algebraic equation. Okay. Once you change your second order differential equation with constant coefficient homogeneous, is becoming, by the substitution y equal to mx, is becoming a m squared plus bm plus c equal to 0. This is what? This is a second degree algebraic equation. You can solve it? Yes, you can solve it. How you can solve this one? You have a formula to solve this one, which is m 1 and 2 will equal to minus b plus or minus root square of b squared minus 4ac over 2a. Okay, this root, how many cases you have for this root? You have 3 cases. The first case, m1 equal to m2, and they are real. And also you have m1 not equal to m2, and they are real. Okay, the last one, it is m1 and m2 are complex root. What does it mean, complex root? It means in the form alpha plus IB. What is I? I is the root square of -1. Okay. They are conjugate because any two complex number are conjugate. It means if you have alpha plus IB, it will be alpha minus IB, the other root. Okay. If you have these two real are equal, so your solution will be the solution will be y equal to C1 e to the m1 equal to m2, I call it equal to m. Okay, just not to write. Okay. So m. So mx okay plus C2. If I write the same m, I have to distinguish this one by x here to be independent solution. Okay. Now, if they are not equal, no need for this one, right? So the solution will be y equal to C1 e to the m1x plus C2 e to the m2x. You have two constants here because you are working in a second order differential equation, right? When we did the first order differential equation, we have only one constant, right? Okay. Now, what about if you have a complex number? If you have a complex number, the solution will be y e to the real part times x, open bracket, and C1 cosine beta x plus C2 sine bx. I will just write it in a nice way. So y equal to e to the real part x, open bracket, C1 cosine beta x plus C2 sine beta x. Okay. This is the three cases of the roots of this algebraic equation coming from the differential equation by this substitution. Okay. Let's have an example for this one. Solve y double dash minus 2y dash minus 3y equal to 0. Y double dash plus y plus y dash plus y equal to 0. Y double dash plus 2y dash plus 1 equal to 0. Now, if I am going to solve this second order differential equation with constant coefficient homogeneous, do I have to follow the same steps here and substitute? Okay, no, straightforward, because I will mention in the beginning here it is the second order differential equation with constant coefficient and homogeneous. Okay, ay double dash plus by dash plus cy equal to 0. By the substitution y equal to mx, it's becoming a m square plus bm plus c equal to 0. This is my GPS. So I will go to the number 1. So y double dash minus 2y dash minus 3y equal to 0. It will be changed into what? Guys? This one
1m squared.
M squared. Yes.
Minus 2m.
Yes.
Minus 3.
3 equal to 0. How to solve this one? You can factorize or you can use your calculator. So m and m here. So this is minus. So one of them will be minus and the other one will be positive. 3 is a prime number, so it is only 3 times 1. The bigger one will be close to the sign as the midterm, right? So the 3 will be here and the 1 will be here. Now this one gives you m equal to what? 3 and m, the other m equal to what? Minus 1. So what is the solution? Which case this one?
It's real and not equal.
Y equal to C1, yes, e to the 3x plus C2 e to the minus x, okay? This is the solution of this one, right? Okay. Now I finish the first one. Let's go for the second one. Y double dash plus y dash plus 1 equal to 0. Straightforward without thinking. I'm just saying y equal to e to the mx. Okay, so I will have what? M squared plus m plus 1 equal to 0. Can you factorize this one? Of course not, right? So a here is 1, b here is 1, c here is 1. So I will have m equal to minus b plus or minus root square of b squared minus 4ac over 2a. If you have your calculator and you can do it, that's fine. So minus 1 plus or minus root square of minus 1 square, so it will be minus 4 times 1 times 1, okay, over 2a is 1. So you end up with minus 1 plus or minus, this is root square of minus 3 over 2. This is what? Yes.
Root square of 3i.
Minus 1 plus I root square of 3 over 2 plus or minus. So this is which case?
Third
yes,
case.
This is the case when you have a complex number, right? Okay, so the solution is, the solution is y equal to, yes, e to the, what is the real part? Yes, I have to put this one as minus 1 over 2 plus or minus I root square 3 over 2. Why I put this one? Just to follow the case. This one, the real e to the real part times x, c1 cosine the imaginary part times x as the angle, plus c2 sine the imaginary part times x without the I. Okay. E to the minus half x. Okay. And then open bracket c1 cosine, what is the real part? Root square 3 over 2 x plus c2 sine root square 3 over 2x. Okay, finish. Let's go for the last one. Y double dash plus 2y y double dash plus 2y dash plus y equal to 0. Without thinking, I'm just letting y equal to e to the mx. So this one will be transformed into what? Yes, into algebraic equation. M squared plus 2m plus 1 equal to 0. Yes, it is complete square. M plus 1 square equal to 0, right? So m equal to minus 1, and also the other root is a repeated root. So the solution is, yes, y equal to c1 e to the minus x plus c2. I have to make this one independent, so I multiply by x e to the minus x. This is the solution in this case. Now we go through the three cases. Okay. What is the point of studying this one as electrical engineering students? If I go to the RLC circuit, and I will have a DC source, DC, okay, direct current. So the direct current is always constant, like a battery or something. So I call it E naught. And you have conductor, coil with conductance equal to L. And you have capacitor, have a capacitance equal to C, and normal resistance R. And this is a series circuit. If I'm asking you to write the mathematical modeling for this one, yes, I know the voltage in the R is I times R. So yes, I R plus, what is the voltage in the coil? L di by dt. Plus, yes, for the capacitor, 1 over C, the integration of I dt, equal to what? Up to Kirchhoff law, the input is equal to the output. So you have E naught. So this is E naught. Now I would like to get rid of the integration to have differential equation. So what I'm going to do, I'm going to differentiate with respect to the independent variable t. So what I have, when I differentiate d by dt for E naught, and E naught is constant, so you will have what? You'll have 0, right? Equal to R is constant, and you differentiate the current because the current is changed. Sorry, I have to use the same symbol. Okay. Di by dt plus L d square I by dt, and I end up with, when you differentiate the integration, you will have the original function I. Now, this 0, I just order them, L d square I by dt square plus R di by dt plus 1 over Ci. This is what? A second order differential equation. This is second order. Homogeneous or non-homogeneous? Homogeneous. Because I don't have a function of the independent variable t in the left-hand side. Homogeneous, yes, with constant coefficient. So you can solve it as normal. You just let I equal to e to the mt. So this one will transfer into what? Yes, 0 equal to L M square plus R M plus 1 over C. Also, you have how many cases you have? You have 3 cases. M1 not equal to M2, and they are real, and also real roots, but they are equal. And also the last one as a complex root. Alpha plus or minus I beta. This is the 3 cases, and you can go through and find the current, right? Okay. This is the point of studying the second order differential equation. And if I give you the value of R and C and L, so you can find the current in terms of the time t. If you have initial value like the current in the beginning equal to 0, you need another initial value because you have second order differential equation, and also I dash of 0 equal to 0. So this is, if you have this one with this one, they call it the initial value problem. So the initial value problem will give you the solution without any constant C1 and C2, right? And they call it the particular solution. Let's go for the second type of the differential equation. Yes, it is non-homogeneous. Non-homogeneous second order ordinary differential equation with constant coefficient. Non-homogeneous, it means the same as mine, but in the other side you have a function of the independent variable t or x. It's up to your problem, right? Now I have cases for this one. I have case 1 and case 2, and right. Let's go and see what is the cases of this one, of the right hand side. This is the cases of the R of x. Okay, you have k or constant times e to the exponential function here, or you have a polynomial of degree n, or you have a cosine or sine function, or you have a mix between the exponential and the cosine and the exponential and sine. What I have to do if I have the right hand side, okay, if I have this right hand side as a function of the independent variable as exponential function, I'm just let the particular solution C. What is the difference between the particular solution and the homogeneous solution? The homogeneous solution was for this one when I suppose this is equal to 0. So what I have to do in the non-homogeneous, the solution has 2 parts. The solution consists of 2 parts. 2 parts. What is these 2 parts? First, YH. YH, the solution for the homogeneous part. Solution of the homogeneous part. And the other one, this is which is new for us, YP, the solution of the non-homogeneous part. Okay, so what is the general solution? And the general solution will be y equal to YH plus YP. Okay, I know how to find the general solution for the when Rx equal to 0. I have no problem. What about YP? YP depends on what? Depends on the right hand side, the non-homogeneous part. As we said, if you have exponential function, you let your particular solution YP as a also constant times the same exponential function. If you have a polynomial of degree n, you also, or any term of degree n, you will let the solution as a polynomial of degree n. And also, if you have cosine and sine, you will have the same particular solution. It doesn't matter sine or cosine. You will have, you consider the solution include both of them. Okay, because we know the cosine and sine coming from the complex case, and e to the I theta is cosine theta plus I sine theta, if you remember this one. Also, if you have a mix between the exponential and the cosine and exponential and sines, you let the particular solution also as a constant times the cosine plus another constant times sine, and multiplied by outside by the exponential function. Let's go and see this case. If you have this one, right? You know how to solve this one. YH now I know this is what? Yes, it is a second order differential equation with constant coefficient, non-homogeneous. So the solution y equal to YH plus YP, where YH is a solution of Y. YH is the solution of what? Yes, Y double dash plus Y equal to 0. How to solve this one? Straightforward. This one will become what? M squared plus 1 equal to 0. So M will equal to what?
Can you make the screen full?
Sorry?
يعني تكبر الشاشة.
Okay. Now I just okay. So now M squared equal to minus 1. So M will equal to plus or minus I, right? So YH is equal to what? YH will equal to C1. This is a complex case, right? Yes. So what is the real part? Alpha equal to 0 and beta equal to 1, right? So the solution will be e to the 0x, and here C1 cosine x plus C2 sine x. Very good. I got the YH. Anything to the power 0 is 1. Now how to find YP? So, and YP is the particular solution. Which case this one? Which case from these cases? Okay. Again. Which case? Yes, this is the case of x to the power n. Okay. So I have to let the solution as a polynomial of degree n. What is the n here? 2, right? So YB will equal to what? YB تمام. يبقى YB since R of X equal to 0 point what? 0.001 x squared, right? So the YP will equal to what? Yes, A x squared plus bx plus c. This method, they call it undetermined coefficient. So I have to find what is A, what is B, what is C. Why? Because the particular solution will never have a constant, right? So what I supposed to do? This is a particular solution, so I should have yb dash, which is 2a x squared plus b, yb double dash equal to 4a x, because any solution must satisfy the equation. Okay, now substitute in this one. I have y double dash plus y equal to 0.001 x squared. Let's substitute in this one. Okay, so y double dash is equal to what? 4ax plus, what is y? Y is a x squared plus bx plus c equal to what? Equal to 0.001 x squared. Now, if I compare the coefficient in the both sides, I have only x squared here, right? So what is the coefficient of x squared is a. So a is equal to what? 0.001, right? This is the point of having the particular solution. Okay. So I substitute instead of a, b, c, he call it k2, k1, k0. Anyway, this is a polynomial of second. I differentiate and substitute. So I will have k2, the coefficient of x squared is equal to 0.01. What about the other coefficient? The other coefficient is what? Yes, the coefficient of x. Do you have x in both sides? No. So 2k2 plus k0 is a constant equal to 0 and k1 equal to 0. Okay, so 2k2 plus k0 equal to 0. I got k2 equal to 0.001. Substitute here, so I will get k0 as minus 0.002. Now my particular solution was k2 x squared plus k1 x plus k0. K1 is 0. K2 is 0.001 and K0 is minus 0.02. This is my particular solution. I just accumulate this together, so I will have the general solution for the non-constant, non-homogeneous second order differential equation with a constant coefficient as a sum of the homogeneous solution plus the particular solution. Okay. This is how to find the. If you would like to check the initial condition, because you have initial condition here, y at 0 equal to 0, y dash of 0 equal to 0. So I have the general solution, which is the sum of the yh plus yb. I just substitute by y dash, okay, which is equal to, so b will equal to 1.5. Okay, and yh. Okay, so I will find the constant b and a from the initial condition, and I will get the solution without any constant. Once you have initial condition, this is initial value problem, so your solution never have any constant. If you would like to graph the last formula of the solution after applying the initial condition, you will have this curve, right? This is the current, sorry, this is the y, depends on x, okay? Now, this is the application. Another application of the non-constant coefficient example here, so you will have yh, which is you take this one, the right hand side, put it 0, and have the roots for the algebraic equation coming from this one. So they call it lambda, they call it m, it doesn't matter. Okay, so lambda square or m square plus 3m plus 2.25 equal to 0. You get the roots. You will have the roots are the same. So this is a second case when they are equal. You multiply the second one by x. Next, you go for the particular solution. The particular solution depends on the right-hand side. This is exponential, so you let your particular solution as a constant time the particular solution. Okay, why this particular solution you multiply it by x squared? Yes, because I cannot consider the particular solution as a part of my existing solution. So I have c times e to the minus 1.5x, and I have c2 times x times e to the minus 1.5. So the particular solution must be independent from this one. This is why I choose yb in this case, independent from this two parts. So I have to get this particular solution c times x squared e to the exponential function. This is very tricky because all the students go for this table, and once they see the exponential function, they consider the particular solution like this. But they didn't think in the case of the root are equal, you will have the same exponential function at the right hand side, and also you have it as the right hand side multiplied by x. So the particular solution to be independent from the homogeneous solution must be different from this one. So I have to multiply it by x again. So this is a particular solution. I would like to just refer to this one because this is a common mistake of the student. Once you have the two parts of the solution, add them together, you will have the general solution. If you have initial value, for y0 and y dash, you need to substitute by y at 0. Okay, and have an equation of c1 and c2, and differentiate this one to have y dash, substitute by y dash from the initial condition. You have a second equation of c1 and c2, solve them together, you will have the constant c1 and c2. Now you can write the equation, the general solution, and you can graph it. Okay. Also here, this is the case when you have cosine and sine and exponential function. X to the power n. What I'm going to do in the particular solution? Shall I go for cosine or sine? Cosine or sine, it doesn't matter because you will have the same thing. But this is the one. Yp will include the case of cosine or sine and include in the case of this one. So Yp here, you have two p's. Yp1 corresponding to the cosine and sine, and the other Yp corresponding to the x to the power n. This is x to the power 1, so you have to let a first degree polynomial. This is also very important because when you have a mix, you have your particular solution will be also a mix. Okay, and you substitute, differentiate, apply the initial condition to have the constant. And then once you have a general solution without constant, you can graph it. Okay, this is what I told you, and we talk about this one. The difference between the homogeneous and non-homogeneous, you have alternating current. So when you differentiate, if you remember, when I differentiate in the case of DC, okay, I have a constant here because I have, when I differentiate to get rid of the integration for the capacitor, I differentiate this side. So because it is constant, the derivative will be 0. But if this one is AC, so you have a function sine or cosine of t or something, right? So when you differentiate, this one will not be c, it will be a function of t. Okay, this is the difference between these two cases. And also you have to get the general solution from the YH and plus Y. This is exactly what I said. Not only to find the current, you can find the charge also, because you know the relation between the current and the charge. The charge equal to the integration of the the charge is equal to the integration of the current, or the current is the derivative of, or the rate of change of the charge, right? This is example of the RLC circuit. Once you put the R value and L value and C value, you will have such second order differential equation with constant coefficient, non-homogeneous, and you solve it by YH plus YP. Okay. We end up with this exercise. How to solve this one by Matlab? Let's go and do it before we finish explaining. Can you do it with me, please? I'll go for the second order differential equation. So this is a higher order, all of them higher order. Sorry, I got this one. So I'll go back to the examples. Sorry, I have to change this one into second order. Let's solve this one, right? Let's solve this one because you would like to have a current in your lab. So you can solve this one. Okay. Can you write the Matlab command for this one and put it in the chat, please? Guys?
Yes, doctor.
Please. You can write since P is my independent variable, okay, semicolon, D solve, the solution will be I, I'll make it I capital, equal to D solve, open bracket. What is the solution here? 0.1 star D2 I. So I have to define I D2I plus 11. I'm waiting your command. I dash, how to write I dash? D I equal to 110. Is this minus or plus?
This is plus. No, before there are 100i.
100. Yeah. So here plus 100 star I, excellent, equal to 110 plus 377 star cosine, open bracket, 377 star T. Finish. Is it correct now?
Yes.
I didn't close this one, right?
Yes.
Are you sure? No. So what's the mistake here? Control C, Control V. Do we have to put this one between this comma?
Yes, and then put comma.
Comma and the
T.
independent variable, right?
Yes.
Now I have the solution. I can use the pretty command to make a pretty for the result. I call the result I before writing the command. I write what is the result coming from this command. So pretty I. So I have this solution, right? Easy. So even if you cannot solve it by hand, you can use if you forget how to solve it theoretically, you can solve it by Matlab. Okay. So I finished my turn. This is your turn now.